So in this lesson, we're going to take a look at sequences. And for our purpose in this class, we're going to be looking at sequences just basically as a list of numbers. And there's going to be some sort of pattern that is formed with them. Now, that does not necessarily need to be true for all these sequences, but for what we're doing here is we're going to be looking at them as just a list of numbers. We're going to have two different types as well. The first type of sequence we're going to take a look at is arithmetic. And what an arithmetic sequence means is that we're going to have the same numbers being added each time, either a positive or negative, and that number is called the common difference. So whether it's a positive or a negative number that is added, we're always going to call it the common difference. I'm going to go a little bit more into that in just a bit. The other type of sequence we're going to look at is called geometric. And with the geometric, there is a common multiplier. Now, if we have a list of numbers that does not have either the same number being added or the same number being multiplied from one term to the next, then it's neither arithmetic or geometric. So let's look at an example. If we look at this list of numbers right here, once we have three of these numbers together, we can figure out if there's a pattern. So right now, from 6 to 10, it is adding 4. And from 10 to 14, it is also adding 4. That means this is an arithmetic, and our common difference is going to be 4. If I want to figure out the next few terms, I'm going to add 4 to get 18, add 4 to get 22, and add 4 to get 26. So our common difference is 4. And another way we can always figure out the common difference is by taking a term, doesn't matter which one, and subtracting the previous term. That's why it's called a difference, because we are using subtraction to figure it out. 14 minus 10 equals 4. And that was the common difference that was being added each time. Now I could also have one that looks like this. In this case, the common difference is negative 3. 7 minus 10 is a negative 3. 4 minus 7 is negative 3. So that's our common difference. My next couple terms would then be positive 1 and negative 2. The next example I'd like us to take a look at is what if we start off with a number like 8, and the next number is 16, and the next number is 32. Well, I add 8, and then, that is not adding 8. That's actually adding 16. Since these two numbers are different, that means this is no longer arithmetic. So now I want to think about geometric. So do I have a multiplier to get from 8 to 16? 8 times 2 is 16, and 16 times 2 is going to be 32. So if I wanted to figure out the next few, I would take 32 times 2 and get 64, and multiply times 2 to get 128. Our common multiplier that we have here, to figure that out, we can do something very similar to the last time. If I take a number and divide it by the previous term, 32 divided by 16, that equals 2. 16 divided by 8 is 2, and is matching our multiplier. This is an example of geometric, because now we have a multiplier. One last example I'd like us to take a look at is this next one. If we have this list of numbers right now, we can tell hopefully right away that we're not adding the same number each time. So again, this is not going to be arithmetic. So now we want to check if it's geometric. But the numbers are getting smaller each time. which means our multiplier is going to be a decimal or a fraction between 0 and 1. So again, to figure out my multiplier, just like we did before, I'm going to take a term, 27, and divide it by the previous term, 81. And I can simplify this down to 1/3. I can do the same thing with the 9 and 27. 9 divided by 27 is 1/3. So I know it seems like the same thing as dividing by 3, but we always want to think of geometric as having a multiplier. In this case, our multiplier is 1/3. So now if I'm multiplying by 1/3 and multiplying by 1/3, that means multiplying by 1/3 here will give me 3, and multiplying by 1/3 here will give me 1.